Hey guys, it's Coach Pointer. So I'm trying to give you a little video to help you with some of the math as we're going through on this. In the folder, Coach Stricker, there's a video there. He does a great job of going through this, but I'm going to try to do a little bit for you here as well so you can see it as you're going through with this. I know that things are a little different, but we'll make it work. And so please don't freak out. Take the time to watch the videos and really try to work through some of this on your own as you go through. A lot of this is just going to be basic math, algebra, solving the equations that we go through with this. But so as we start on that solutions worksheet, question number 16 starts with, what is the molarity of a solution formed by mixing 0.2 mole of sodium hydroxide with enough water to make 150 milliliters of solution? So the formula that we're going to need to utilize is M, which is molarity, is equal to N divided by L. And so N is going to equal to number of moles, and L is going to be volume in liters. So in this scenario here that I have, what I'm going to use is I've got M is equal to the number of moles in that problem is 0.20 mole divided by, then it says 150 milliliters. Well, I need to change that milliliters into liters. So I have to divide 150 by 1,000 or move the decimal 3 places, 1, 2, 3. So my answer is really 0.15 liters. Once I do that, now I take my calculator and I divide 0.20 divided by 1.15, and I'm going to get 1.33 molarity. So that would be my answer. That's the strength of that solution. Now, sometimes, like if you roll down to question number 19, it says, what is the molarity of a solution produced when 145 grams of sodium chloride is dissolved into sufficient water to prepare a 2.75 liter solution? So let's write down what we know. I know molarity is going to be equal to N, number of moles, and then I know my solution is 2.75 liters. Well, it also tells me I have 145 grams of sodium chloride, NaCl. So this is where I have to go through, and this is stuff we've done before. I need to figure out how many moles do I have of sodium chloride. So if I look up on the periodic table, I have to, let me see if I have my periodic table. I look up the mass of so I look up the mass of sodium, which is 23, and then I look up the mass of chlorine, which is 35.45. I add that together, I'm going to get 0.45, 58.45. So to find the number of moles, I'm going to say 145 divided by 58.45. And when I do that, I'm going to get 145 divided by 58.45. That equals 2.48 moles. Now I can solve my problem. My problem is now going to be 2.48 divided by 2.75, and I'm going to equal a molarity of 0.9. And that would be my final answer. So the key thing here is looking at what is given. We always have to get it to moles. So if I'm given to grams, I've got to do where I have to go through and find moles is equal to grams divided by the molar mass. Once I find that, I can now put that into my equation, or making sure that the volume is changed from from milliliters to liters. And so those are that's how we're going to do molarity. The other problem that we see on here as we get through is we say, I'm going to have to work it backwards. It may give you liters and molarity, and it's going to ask you to find for grams. So you have to be able to plug in to our formula that we're utilizing up here, our formula, and then solve. It's just like density. It's being able to plug in numbers and putting that into that and going through with that. So the other question that we might have is when we get down to 22, question number 22. And so with question number 22, let me do this here. Question number 22 now, it says, how much concentrated 12 molar hydrochloric acid is needed to prepare 100 milliliters of a 2 molar solution? So this is where we're getting into concentrations and dilutions. So I have two solutions. My first solution, the formula I'm going to use is the molarity M1 of the first solution, and the volume of the first solution is going to be equal to M2 divided by V2. So remember, M is equal to molarity, or the strength. V is equal to the volume, again, in liters when we look at this. So I have my first solution, and then what am I trying to get to? My second solution. So in this question here, 21, it wants to know how much concentrated 18 molar sulfuric acid is needed to prepare 250 milliliters of a 6 molar solution. So when I look at this, I'm going to write in what I know. I know 18 molar. That's my M1. All right. And I need to find V1. And then I know I'm going to get a solution that is 6 molar, and the volume is 250 milliliters, but remember I need that in liters, so I need to go 2.25 liters. Now all I'm doing is solving for V1, so I'm going to multiply 6 by 2.5, so 6 times 0.25 is going to equal 1.5. And then over here, I have V1, and I have 18, so I have to divide both sides by 18. So divided by 18 equals, my answer, volume 1, is going to be 0.083 liters. All right. Again, it's just being able to plug in and solve for a formula, putting it in what you know. I'm going to use this formula straight up here. V1, M1, V1 is equal to M2, V2. I hope these help. Keep working through it. Email me in the discussion board if you have questions. But read the solutions, write down what you have, and you're going to use these two formulas to be able to work through these. I hope this works out for you guys. And like I said, if you have any questions, post them in the discussion board, and we'll go through there.